I just did a video explaining why we have to separate grounds and neutrals in a subpanel. And then a commenter asked, why do we separate them in the subpanel but bond them in the main panel? The reason we bond them in the main panel is probably one of the things I have to repeat the most on my page that is the biggest misconception people have. The electricity from that transformer will not flow to ground. That transformer, the way it's designed, and just because of the physics of electricity, the electricity will not leave that transformer and go into the ground. We bring the earth involved in the circuit with what we do with ground rods and things like that. But on its own, the electricity from that transformer will not just flow off into the earth. So if we want proper grounding, bonding to the neutral is required. Let me draw it out on the whiteboard and show you. Okay, clarification of some terms. When I say electricity, I specifically, again, am talking about what comes off the transformer. And I talk about static and lightning. And when I say flow, I mean electrons flowing and moving at a fast enough rate, at a good enough connection that it benefits electricians with tripping breakers or running equipment. I don't mean in some way that I'll lose a bet to an engineer because of some subtle thing that goes on with the magnetic fields and assist electronics. I'm talking to electricians right now and what we do to operate equipment and trip breakers in safety situations. All right, let's get into it. All right, this is our transformer. There's three connections, the red, black, middle is the neutral. The electricity can only flow and make connections from here to here, or it'll make the connection the other way, or each one of these can make a connection to the middle. Those are the paths electricity will flow in. It cannot flow off to magical dirt area, soil, earth, magicness. Okay? It will only flow in the three connections or four connections between those three wires. Okay? Now we have a piece of equipment. This is the motor, a light bulb, whatever this piece of equipment is. This is the hot wire coming into it, running the piece of equipment, and the neutral returning its flow so that the motor will run. Now to make that happen, we have to extend a connection of the hot wire. This is a 120 volt motor to that hot and extend a connection to the neutral to there. So now the electricity leaves that hot, runs through your motor, and goes back on the neutral. 120 volt motor working fine. All right, now it's running. But what would happen if this hot wire was chafed or nicked and came in contact with the metal casing of this equipment? The outer metal casing becomes energized, and now anyone touching it becomes energized. So we want a way to keep this outer casing safe to touch. So what we want to do is set it up so that if electricity does touch this, it has a low resistance path straight back to the neutral and pops open the breaker. And it creates an overload situation by touching the casing. And the way we do that is at the meter or the main breaker, the first point of disconnect, we take a wire from the outer casing and connect it to the neutral. So now when this becomes live, this casing becomes energized, this wire will become energized, and now the hot wire ahead of the motor, if there was a nick, connects to the neutral through the ground, totally overloading it and tripping the breaker. Now the next thing we do, if something was to go wrong on a different circuit and energize the dirt, this is grounded, which is essentially 0 volts, and the dirt and the earth could become energized, and the electricity now is a shock hazard that way. So we also want a way to make sure the dirt has the same voltage reference as the casing. So what we do for that is, at your meter or your main breaker, your main panel, we drive a wire here and connect it with ground rods to earth. And then at the telephone pole, they drive another wire and connect it to the earth. So now, if this wire was to completely break free of the casing and fall into the ground, the electricity isn't going to go up and through you this way. The electricity is going to go up into the ground rods to get back to the transformer that way. Generally, when you have the connection through earth, it's not enough of a flow or a low enough a resistance to open the breaker the way the connection straight to your casing is, but it is enough to remove any differences between this dirt and that casing. So the shock hazard is removed if the soil had electricity coming into it from the transformer. Now this is what it ends up looking like. This is a subpanel. Hot, hot, neutral, ground, not together. Subpanel, hot, hot, neutral, ground, not together. But in the main panel, you got the hot, hot, the neutral, and the ground. When the neutral and ground enter the main panel, where the first point of disconnect is, it's going to be a main panel, maybe a meter socket, but one time they connect in order to create this connection. This happens one time. Throughout the house, they stay separate, but that one time here, they connect. All right, let's see some of those connections in real life. Here is 2 huts and a neutral. Goes up through the meter, down, and right here, right at the first breaker, first point of disconnect, all my neutrals and grounds come together. This strap right here is the neutral coming from above. All right, let's see what that looks like at the transformer end. All right, now let's look at those connections on the transformer end. So the transformer has those 3 connections. The 2 outer ones are the hot wire, the 2 hot wires. That middle one is the neutral. You can see how it jumps from that center pin to the can. So that's ground in the can, or bond in the can. And then we follow it, it goes to here, which now if we zoom out, after it comes off there, one goes down that weatherhead to my house right there. And the other one on the around the back side connects to that guy wire, which then goes down into the earth. Now, I've showed this before in videos, and I've been told industry standard at other parts of the country is they don't use the guy wire as a connection to the earth. They run a separate wire down the pole. But my utility company, for whatever reason, does it this way. I am not a utility guy. I can't tell you which is better, which is worse, what's the reason for doing the 2 options. But right there is just like in the drawing. All right, thank you very much.